We are going to continue to look at the idea of genetic variation, but for this particular video we're looking at the inheritance of gender. Now we're going to start off with a fertilized egg, and as we know, if we've watched previous videos on this topic, a fertilized egg for humans contains 46 chromosomes, and out of those 46 chromosomes, 23 come from the father and 23 come from the mother, and I've just very roughly drawn that out over here. Now what we can do is we can actually match up all the chromosomes from the father. So let's just say the father's chromosomes are purple. We can match each one of those up with all the chromosomes from the mother. So this will take ages to do, so I'm going to speed it up a bit. There you go. So we've matched up all the chromosomes from the father and the mother, but sometimes we come across a little scenario where we have two last chromosomes that we have left and they just don't seem to match. This one has kind of an X shape, so we call that the X chromosome. This one has a kind of a Y shape, so we call it the Y chromosome, and these are actually the sex chromosomes, or the sex determining chromosomes. And if you have an X and a Y chromosome, that makes you male. And the other possibility is if you have X and X. Let's put that down here. Two X chromosomes, and that will make you female. So in this example here, this is an example of a set of chromosomes from a boy, because we have X and Y. If it was a female, a girl, it would be X and X. Now that's important to remember. So all males have X and Y, all females have X and X. But how does that help to determine whether a baby is going to be a boy or a girl, or what are the chances of getting a boy compared to the chance of getting a girl? Well, let's have a look at this little couple here. They are trying for a baby, and as we know, the male has X and Y and the female has X and X. Now when the male produces sperm, he can only pass on either an X or a Y into the sperm cell. He doesn't pass on both of those into one sperm cell. Similarly for the female, she will either pass on an X or an X. So in other words, she will pass on an X into the egg cells that she produces, and so we have this scenario here. Okay, so the sperm cell will either carry an X chromosome or a Y chromosome, because it can't carry both because of meiosis, which you can go back and look at in your own time. The female will produce egg cells or gametes that have the X chromosome in them. Now, what are the possibilities of having a boy or a girl? Well, if we look through this scenario here, let's have a look and see. We could have this sperm cell here fusing or joining with that egg cell, and that would give you X and X, and therefore that will give you a girl. Another possibility is that this sperm cell could meet not with this egg cell but with this one here that I've done in green. Incidentally, I've just done the colours so that we can see where the chromosomes are coming from. In the exam they are very unlikely to be giving you colours, but once you go through this, hopefully you'll understand it. So now we've got the second sperm cell, which has a Y chromosome. Now that sperm cell could meet the first egg cell, and that would give you Y and X, or the sperm cell could meet this egg cell. So what we have over here is girl, girl, boy, boy. These are all the possible things that can happen. So what we have is the chances of a girl is 2 out of 4, and the boy is 2 out of 4, and in fact you would say you could say in a variety of ways 50% chance for a boy. You could say 1 out of 2 if we cancel this fraction down, chance of a boy, or we could say a ratio of 1:1 for boys to girls. Okay, so this is a way of showing what the possibility of inheriting or having a baby boy or having a baby girl. There is one other way we can do this, and that is using what we call a Punnett square. And we'll probably be using this in some future videos to work out genetic crosses. But the way this works is you do a noughts and crosses type grid. You put the mother's chromosomes along the top, so she can give either an X or an X, and the father's along the bottom, or along the side should I say, so he can give an X or a Y, and then all you do is just fill in these squares by bringing down the X's or the Y's that we have. So X and X over here, so that we have xx, so this x with this x will give you two x's, this y with this x, and this y with this x. Okay, so that's another way of doing it. It doesn't matter if you have the male on the side or the female on the side, as long as you have one of each one on the top and on the side. So this is one way to work it out, and again you can see we have two female and two male, and again you get all these percentage, fraction or ratios. Okay, so hopefully that makes some kind of sense. You should be able to explain how the inheritance of gender or the inheritance of sex works based on this idea here. Thanks for watching, and see you again soon.